In this video, I will give you 100 questions and answers to prepare your Solidity job interview. Questions will be of different difficulty, starting from easy, going to intermediate, and all the way up to difficult. It covers the most important aspect of Solidity, smart contract, and Ethereum. So after you went through this 100 questions, I guarantee you that you're going to be really ready for your job interview. And even if you're not preparing a job interview, it's still very much worth it to watch the video because you're going to learn a lot of stuff that you didn't know about Solidity. By the way, this video is sponsored by EtherBlocks Pro, my screencast for Ethereum and Solidity smart contract developer. If you want to access the source code of all my other video tutorials on Solidity and Ethereum dApps, you can create a free account on EtherBlocks Pro. Alright, so now let's get started, and we're going to start with the easy questions. What is an Ethereum smart contract? It's a small program that runs on the Ethereum blockchain. What makes an Ethereum smart contract so special compared to other programs? Once an Ethereum smart contract has been deployed to the blockchain, it cannot be stopped. Even if you are the creator of the smart contract or the government or even the developer of Ethereum, nobody can stop a smart contract once it has been deployed. It also cannot be hacked, as long as the code of the smart contract is correct, of course. If there is a bug in the code, then of course your contract can be hacked, like what happened to the DAO. And it's also not possible to modify a smart contract. Just to be specific, the part that cannot be changed is the code, so we said that the code is immutable. However, the data of the smart contract can be modified. Can a smart contract interact with other smart contracts? Yes, and that's actually what makes smart contracts so powerful. Any smart contract can call function on other smart contract and trigger a sort of chain of execution through the blockchain. Can a Solidity smart contract call an API on the web? No. A smart contract can only execute its own code and interact with other smart contracts on the Ethereum blockchain. If you need your smart contract to interact with an API on the web, the pattern you use is the Oracle pattern, where an external API calls a function on a smart contract and feed it with some data. And after that, the Solidity smart contract can make use of this external data that was imported in the Ethereum blockchain. But it's always from the outside world to the blockchain and never the other way around. Can a Solidity smart contract store a lot of data? No. In a smart contract, storing data costs gas, and gas consumption is capped in each Ethereum block, so indirectly storage is limited. And also, since it costs money to store data in a smart contract, you probably don't want to store a lot of data anyway. Can a smart contract be written in another language than Solidity? Yes. There are other smart contract languages like Viper or LLL, but Solidity is by far the most popular. Is Solidity a dynamically or statically typed language? It's a statically typed language, which means that variable types need to be defined. That's different from languages such as JavaScript, where you don't have to do this and you can just define your variable and use them right away, and the language figure out the type of the variables. On the blockchain, we have to be a little bit more careful about what we do, because after we deploy a smart contract, we can't modify its code. So if there is a bug, it's a big problem. And one way to be really careful is by defining the type of every variable, and by being this explicit, we reduce the chances of making errors. Is Solidity compiled or interpreted? It's compiled. That means that before we're able to run a smart contract, we need to first compile it. That's different from JavaScript, where after you finish writing your code, you can run it directly. The JavaScript virtual machine will compile your code on the fly. That's called just-in-time compilation. But we don't have this in Solidity. What is the file extension of Solidity files? .sol. Pretty simple. Can a single Solidity file have several smart contracts? Yes. You just have to use the contract keyword several times. Actually, when you deploy your smart contract, oftentimes it's more convenient to put all your smart contract in a single file. However, in general, it's better to have a single smart contract in a single Solidity file for better code organization. What is the typical layout of a Solidity smart contract? First, you need to put the pragma statement to indicate to the Solidity compiler which version of Solidity you want to use. This is for avoiding mistakes where you write the smart contract for a version of Solidity, but you accidentally used another version when you compile the smart contract. Next, you need to declare your smart contract with the contract keyword. Everything which is between the curly brackets is part of this smart contract. Then you can define some variables in your contract, and then you define some function to be able to read some data or modify some data. What is the difference between state and local variables? State variables are persisted on the blockchain after a smart contract finished to execute, whereas local variables live only during the execution of a function. What is the problem with the following Solidity code? The set function redefines the data variable inside its body. This will create a local variable that will shadow the state variable defined above. To fix the code, remove the address keyword when you reference data inside the set function. Another question about what is the problem with the following code. This is similar to the problem we had just before. The data argument of the set function shadows the data state variable inside the function. Because of this, we can access the data state variable inside the set function. To solve this problem, we need to rename the argument from data to _data. What are the two variable visibilities for state variables in Solidity? Private and public. Who can read private and public variables? Private variables can be read only by function inside a smart contract, and public variables can be read by anyone. What is the default visibility of state variables? Private. Are private variables really private? No, actually private variables are only private for the EVM, which is the Ethereum virtual machine, the part of the Ethereum that executes smart contracts. But the data of smart contract is put on the Ethereum blockchain, and all data on this blockchain is public. You can use a special tool to analyze blockchain data, and you will be able to read any variables, including the private variables of smart contracts. So private variables aren't really private, it's just that it's a little bit harder to read them. How to deal with private data then? You either don't put private data on the blockchain or you put hashes of data. Mention 3 data types that you use often and explain why. uint, the integer type, is used mainly for Ether and token transfers. Address is used for identifying humans and smart contract. And finally, strings are used for naming things. What are the 2 container types in Solidity? Mappings and arrays. How to declare an array of integer in Solidity. How to declare a mapping of address to booleans in Solidity. In this example, address is the key and boolean is the value. How to declare a mapping of address to a mapping of address to boolean, so in other words, a nested mapping. The way you do this is by using the mapping keyword inside a mapping. So the first key is address, then you have a second address key, and finally you have the boolean value. How to add data to an array declared as a state variable. You basically use the push method. How to add data to a mapping declared as a state variable. You need to use the bracket notation and to specify which key you want to access. How to loop through an array. You have to use a for loop. First you define an initial condition, then you define a stopping condition, then you define what happened at every increment, and inside you write the code that will be executed for every pass. What is the difference between a uint 8 and a uint 16? uint 8 can store numbers of up to 2 power 8 minus 1, so that means it has 8 bits, whereas uint 16 can store numbers of up to 2 power 16 minus 1. What are the 4 function visibilities in Solidity by increasing permissiveness? The most strict visibility is private. That means that the function can only be called from inside the same contract. Then you have internal, which means it can only be called from inside the contract or another contract that inherits from it. Then you have external, which means the function can only be called from outside the smart contract. And finally, you have public, which means it can be called both from function inside the smart contract and also from outside the smart contract. How to conditionally throw an error with an error message. For that, you will use a required statement. First, you specify what is the testing condition, and if this condition fails, the second argument is the error message. What are the 2 artifacts produced by the Solidity compiler when compiling a smart contract? The ABI and the bytecode. What is the ABI of a smart contract? The ABI defines the interface of the smart contract, which means the set of functions that can be called from outside the smart contract. It is used to interact with the smart contract. The API is used outside of the smart contract by Ethereum client libraries like Web3. The API only defines the function signatures, so that means the function name, the argument types, and the return types, but it does not define the implementation of the function. The API also defines the events of the contract. In the following contract, which function will be part of the API? Foo and Bob will be part of the API. Baz is internal only and can be only called from inside the smart contract, so there is no point in putting this in the API. Does the EVM understand Solidity? No, the EVM only understands bytecode which must first be produced by Solidity outside of the blockchain. What is the EVM bytecode? The EVM bytecode is a series of EVM elementary instructions called opcodes. These opcodes define very simple operations like adding two numbers, loading data from memory, etc. etc. There are more than 100 of these opcodes defined in the Ethereum yellow paper. Coding directly with opcodes would be very tedious, so we need higher languages like Solidity to help us reason at a higher level of abstraction. What are the two API used to interact with the smart contract? eth_send transaction and eth_call. Transaction costs money and can modify the blockchain. Calls do not cost money and cannot modify the blockchain, but can return a value contrary to transactions. What is gas? It's an abstract unit to measure transaction cost. How is gas paid? Gas is paid in Ether using the formula Ether cost equals gas price times gas, where gas represents the gas cost of the execution of a transaction. Gas price is in Gwei per gas, generally expressed in Gwei. It is set freely by the sender of the transaction. A transaction also specifies a gas limit parameter which specifies a maximum number of gas that can be paid by a transaction. Without this, a transaction could potentially drain an account of all of its Ether. What happens if there is not enough gas in a transaction? The transaction is stopped and all state changes are reverted. Who pays for gas in a transaction? The sender of the transaction. What is the most famous IDE for Solidity? There are quite a few IDE for Solidity, but the most famous by far is Remix. To use it, you only need to go to this address in your browser. No need to install anything. Besides a code editor for Solidity, you can also run an in-memory blockchain that you can use to develop your smart contract. These two famous frameworks for Solidity smart contract development: Truffle and OpenZeppelin. Truffle is the most popular framework for developing Solidity smart contract. It allows you to easily deploy your smart contract to a development blockchain and interact with it. OpenZeppelin provides reference implementation for a lot of token standards like ERC20 or ERC721. So before you create your own smart contract, you should always check out if OpenZeppelin doesn't already have an implementation that you can reuse. Which JavaScript Ethereum client can we use to develop Solidity smart contract on a local blockchain? Ganache. Ganache is a CLI tool that you can use to automatically start a development blockchain on your computer. This development blockchain is a safe box that you can use to develop your smart contract. It's not connected to any public Ethereum network, and every time you start it, it starts with a fresh blockchain with no data on it. It also comes with 10 preloaded Ethereum accounts that you can use to develop your smart contract. All the Ether that you use on this blockchain is a fake Ether, so you can spend it all, it's no problem. What do you need to deploy a smart contract to the Ethereum network? You need the bytecode of the smart contract. You need an Ethereum address with enough Ether to cover transaction cost. You need a wallet to sign the transaction. And you need a tool to create the transaction and coordinate the signing of the transaction with the wallet and then sending the signed transaction to the Ethereum network. List 4 famous Ethereum wallets: MetaMask, MyEtherWallet, Ledger, and Trezor. MetaMask is probably the most famous Ethereum wallet. It's a browser extension available on Chrome and Firefox. Most apps make sure that it works with MetaMask because it's what most users are using. MetaMask stores private key in the browser and it requires a password in order to be used. MyEtherWallet is a website that has a wallet functionality. Ledger and Trezor are two hardware wallets. They can store Ether, but also Bitcoin and many other coins. They are not as easy to use as MetaMask and MyEtherWallet, but they are way more safe. Usually it's better to put most of your money on a ledger or a Trezor, and in MetaMask or MyEtherWallet you will just put some small change in order to use some dApp. List 3 networks where you can deploy a Solidity smart contract. The most famous one is mainnet, so that's the quote-unquote real Ethereum network where we manipulate real Ether. That's the equivalent of a production deployment in the world of web application. Then you have Ropsten, which is a public testnet. So before you deploy to mainnet, you always deploy first to Ropsten to make sure that everything works fine on its test network. The Ether you manipulate on Ropsten are not really real Ether, so it doesn't matter if there is a bug or if some of these Ether are lost. Ropsten can be used with any Ethereum client. So it doesn't matter if you run Parity, Geth, or any other, Ropsten works with everyone. And another network that we can deploy to is Kovan. Kovan, like Ropsten, is a public testnet where you can deploy your dApp before you deploy it to the real network mainnet. So Kovan is specific for Parity client. It doesn't run on other clients. There are quite a few other Ethereum networks, but the 3 ones I just mentioned are among the most used ones. Next, we're going to switch to the intermediate question. It's going to be a little bit more difficult, but most employers will. But keep in mind that for most Solidity development position, most employers will expect you to be able to answer these questions. So let's keep going. How to manage dates in Solidity. So Solidity doesn't have a native date type. The way we manage date in Solidity is by using timestamps in seconds. We store this large integer in uint variables. How to have the current timestamp in seconds? You just have to use the now built-in variable. How would you build a timestamp of 1 day in the future? So you would use the now keyword, which will give you the current timestamp in second, and to this you will add 80,400, which is the number of seconds in 1 day. What are the 2 ways of defining custom data structure in Solidity? You can use struct or enum. When would you use a struct versus an enum? Struct are for representing complex data structure with different fields, a little bit like object in JavaScript. And enum are for creating a variant of the same data. So for example, a color can have different variants like red, blue, or yellow. You can combine both because an enum can be a field of a struct. What are the 2 ways to instantiate a struct? First, you can pass an order list of arguments. In this case, the order of arguments matter. And the other way is by using the curly braces notation where you have to specify the name of the arguments. In this case, the order of the argument does not matter. How to instantiate a struct that has an inner mapping. So for this, let's consider a struct that is called user and that has 3 fields. So first, it has an address ID field, then it has a string field called name, and finally, it has a mapping field called friends, and this is a mapping of address to Boolean. So let's assume that the user struct is stored inside a mapping. So we're going to call this mapping users, and that's a mapping of address to user. So the problem when you have a nested mapping in a struct is that it's not possible to instantiate a mapping in memory and after assigning to the struct. Mapping can only be with a memory location storage. So the way you're going to get around this is basically you are going to reference a struct that does not exist yet. So you reference the user's mapping and then you reference an entry that does not exist yet, because it's possible to do this in Solidity mappings. And you're going to assign the different fields, so ID, name, and for the mapping, then you're going to reference the key of the inner mapping that also does not exist. And finally, you assign the value of this inner mapping. It's not very intuitive, but it's how you instantiate an inner mapping in Solidity. When would you use an array versus a mapping? You would use an array if you want to be able to iterate through a collection of value. And you want to use a mapping if you want to be able to do a quick lookup for a specific value. How to combine array and mapping to allow both iteration and rapid lookup for a struct. So first, let's consider this struct. This struct has 2 fields, an integer field and a string field. So first, we are going to define an integer array that will store all the ID fields of the user struct. This way, we can iterate through all the user IDs. Then we are going to define a mapping of integer to user struct. The keys of this mapping will be the user IDs. If we need to rapidly look up a user and we already know its ID, then we can use the mapping and quickly get the user struct. And if we need to iterate through all the user, then we're going to create a for loop with the user IDs array. And inside this for loop, we're going to use the user's mapping to get each user by its ID. How to define an in-memory array of 3 integers. First, you define an integer array with the bracket notation. Then you use the memory keyword to specify that this will be an in-memory array. Then you define the name of the array. Then we need to instantiate this array. And for that, you use the new keyword. You use uint again with the bracket notation. And after that, between parentheses, you give the length of the array. So that means that an in-memory array needs to have a fixed length. It cannot have a dynamic length like you have for storage array. How to add value to an in-memory array. So with in-memory array, you don't have access to the push method of storage array. Instead, you need to assign a value to a specific index in an array using the bracket notation. How to get the list of all the keys in a mapping, a little bit like object.keys in JavaScript. It's not possible. Smart contracts don't keep track of the list of entries in a mapping. You need to already know which key you want to access, or you can store a list of all the keys in a separate array. How to create an in-memory mapping in Solidity. It's not possible. The memory location of mappings can only be storage. What happens if you access the key of a mapping that does not exist? Solidity will return you the default value of the type. For example, let's say that we have a mapping of integer to boolean. If we try to access my map of 10 but that this entry does not exist, it will return false because the default value of a boolean is false. This behavior is different than arrays. If you try to access an element of an array that does not exist, there will be an error. With mapping, there is no error. What are the 3 mechanisms for code reuse in Solidity? First, you have a function. So if you notice that there are a couple of places in your code where you use the same code, then you can group this common code in a single function. Then there is code inheritance. So like for other programming language, then you can have ancestor contract and a child contract that inherit from ancestor contract. So this way you have a basic code in the ancestor contract and each child contract can extend this code. For example, if you see the code of the OpenZeppelin framework, you will see that they make a heavy use of inheritance in the Solidity. How to make a contract A inherit from a contract B in Solidity. So first you need to import the ancestor contract with the import keyword. Then you need to make your child contract inherit from the ancestor contract using the is keyword. And finally, if the ancestor contract has a constructor, then you need to call this constructor in a constructor of your child contract. If a contract A inherits from another contract B and both contracts define the same function foo, which one will be resolved in a contract A? So in the first case, if both functions have exactly the same function signature, then the function foo of the contract A will be resolved. The implementation of a child contract always overrides the implementation of an ancestor contract. However, in the second case, the function signature of foo in contract A does not match the function signature of the function foo in B. So for example, on the contract A, if you try to call foo and you give it an argument, for example, the integer 1, then the foo function that will be resolved will be the foo function of contract B, not foo of contract A, which doesn't take any argument. So you need to be careful of function signature when you deal with a function override. What are the 4 memory locations of Solidity? Storage, memory, stack, and cold data. What is the default visibility of state variables? Private. That means that only the smart contract can have access to them. What is the difference between address and address payable? Solidity can only send Ether to an address payable. Keep in mind that this is only a Solidity thing, and outside of Solidity, Ethereum does not make any difference between address or address payable. They are just regular addresses for everybody. Is it necessary to declare an address as an address payable if you want to be able to send it an ERC20 token? No. You need to use address payable only if you want to send Ether to an address. Tokens are different. What are the main changes in Solidity 0.5 compared to Solidity 0.4? The constructors are now declared with the constructor keyword. Before, you needed to create a function with the same name of the smart contract. The address type has been split into two subtypes, address and address payable. Only the second type of address can receive Ether. The var keyword has been removed. Events need to be emitted with the emit keyword. For dynamic length type like mapping and arrays, the memory location need to be explicit. The function visibility also needs to be explicit. Give 3 ways to save gas. First, you can put less data on chain. You need to only put what is really important on the smart contract, and all the rest can be put off chain. Next, you can use events instead of storage. And finally, you need to optimally order your variable declaration. How would you optimally order uint 128, byte 32, and another uint 128 to save gas? So you will declare the two uint 128 next to each other and after the byte 32. So the EVM stores variable in 32 bytes slot. However, Solidity is smart enough to pack into a single slot several variables if they can fit together. So for this optimization to work, the packed variables have to be defined next to each other. In the above example, the two uint 128 will be placed in the same 256-bit slot because 128 plus 128 fits into a 256 slot. How to concatenate two strings in Solidity? First, you need to use the abi.encodePacked function and pass it the two strings that you want to concatenate. This will produce a variable of type bytes. And then all you need to do is to use the string operator to cast this byte into a string. You will find some other tutorials with more complex method, but what I'm showing you here is really the most simple way to do it. How to get the length of a string in Solidity. So there are no straightforward way to do it, but what you can do is to cast your string into a bytes, and once you have your bytes variable, then you can access the length field on it. How to create a smart contract from another smart contract. So first you need to import the contract to create. So either use the import keyword, or in this example we actually define the two contracts in the same file. And after, from the smart contract from which you want to create the other smart contract, then you're going to use the new keyword followed by the name of the contract to create, and between parentheses you're going to pass a parameter if you need to give argument to the constructor of the new contract. How to call the function of a smart contract from another smart contract. So like before, first you need to import the smart contract to call. So either you use the import keyword or you define both contracts in the same file. And after, you're going to reference the contract to call, and between parentheses you're going to give the address of this contract. So that means that your smart contract needs to know the address of the contract to call. And finally, you're going to add a dot plus the name of the function to call. How to get the address of a smart contract that was created from another smart contract. So after you use the new keyword and you create the new smart contract, then you're going to cast the result with the address operator, and this will give you the address of the new smart contract. What will be the value of msg.sender if a contract calls another one? Alright, so let me describe the situation. So we have two contracts. So first we have the contract A, which is the inner contract, and then we have contract B, which is the outer contract. So inside the contract B, we have a foo function that's going to create a new instance of contract A, and after on this contract, it's going to call the bar function. And if you look inside the contract A, the bar function, what we want to know is what will be the value of msg.sender inside this bar function. So msg.sender will not be the address that called contract B, but instead msg.sender will be the address of contract B. How to transfer ERC20 tokens. So in this example, there are two contracts. First, there is the interface for ERC20 tokens, and then I have another smart contract that I call decentralized exchange. So this decentralized exchange smart contract has a function transfer token that allows anyone to transfer its ERC20 token to another address. Actually, if you just want to transfer a token, you just need to define in the interface the transfer function and the transfer from function. I put all the other functions just to show you everything, but if you don't use them, you don't need to put them in the interface. So in your transfer token function in your decentralized exchange, first you need to instantiate a pointer to your ERC20 contract. So you do this by using the interface that you just defined, and you pass to this interface the address of your ERC20 token, And after, you can call any function on this smart contract. So the most simple function for ERC20 token is the transfer function, and this function takes two arguments. First argument is the recipient, and second argument is the amount of token to transfer. It's also possible to do delegated transfer using the transfer from function that is used in combination with the approve function that need to be called before transfer from. How to declare and emit an event. First, you need to declare the event at the contract level using the event keyword, the name of the event, and the description of its fields. You can use standard Solidity types for its fields. Then, inside a function, you will emit an event using the emit keyword, the name of the event, and you will give the argument for the field of the event. If you see some Solidity code version 0.4, you won't see the emit keyword. It was added in Solidity 0.5. What is the index keyword in event definition? It means that external entities can filter only events whose field match a specific value. For example, in the below example, it means that it's possible to filter events where the two fields have a specific value. How many event fields can be marked indexed? 3 maximum. Is it possible for a smart contract to read the events emitted before? No. Only external entities can query events. Is it possible to delete or modify a past event? No. Events are immutable. In Solidity, how to do like a JavaScript console log for debugging. Unfortunately, there is no equivalent of this in Solidity, but you can emit an event and inspect the transaction log. Using this trick, you can log some value even though events are not really designed for debugging like this. How would you implement access control without using a modifier? So for this, you're going to use the require statement of Solidity. So the first argument of the require statement is the condition that you're going to test. So you're going to compare the msg.sender to a predefined address. And if this is not truthy, you're going to display an error message, which is the second argument of the require statement. How would you implement access control with a modifier this time? So we're going to reuse the require statement that we used in the previous question, but we're going to move it to a structure called modifier. So modifier are a piece of code that you can run before function. So first you define the body of the modifier, then you define a placeholder underscore. So this represents the function to which the modifier will be attached. And then you attach the modifier to a function. So you do this in the function signature. So that guarantees you that this modifier is going to be run before the function you're executing. And if this modifier throws an error, then the function will not be executed. How to cancel a transaction. Once a transaction has been sent, nobody can prevent it from being mined by a miner. But you can still send another transaction that will sort of compete with the first one and prevent the first one from being executed under certain condition. This second transaction needs to have the following properties. First, it will have the same nonce as the first transaction. So the nonce is an incrementing integer that is sent in each transaction and that is specific to each Ethereum address. It will have a higher gas price than the first transaction. And when it comes to what the transaction will actually do, it can be sending a tiny amount of Ether to another address or triggering a function call with invalid argument. What really matters is that this transaction needs to do something because it's not possible to send empty transaction. The most important is that the nonce is the same and that the gas price is higher than the first transaction, so that miner will pick up on this transaction first because the higher gas price is more interesting for them. Alright, so we are done with the intermediate question, and next we're going to enter the difficult section. So you might not be asked this question for all your Solidity job interview, but some companies might ask you for this. So if you really want to be 100% ready, then do follow this section. And it's also a good way to push your knowledge in Solidity. What is the ABI encoder v2 pragma statement? This is a pragma statement that is used to enable experimental features not yet enabled in standard Solidity. For example, it enables to return a struct from a function called externally, which is not possible yet in standard Solidity. Is it safe to use the ABI encoder v2 pragma statement in production? No, it should only be used in development, not in production. Is it possible to send a transaction without requiring users to pay gas? So that's what we call a gasless transaction. And yes, it's possible. So the way it works is you would ask users to first assign a message on the front end. Then the message and the signature would be sent to a centralized backend. So that would be in your application and that would be off-chain. And this backend would create a transaction and embed the payload, so the message plus the signature, into it. That means that the gas fees will be covered by the wallet of the app instead of the user wallet. On-chain, a smart contract will verify the validity of the signature and perform an operation on behalf of the user. Which Solidity function would you use to verify a signature? You need to use EC-recover. What is a library in Solidity? A library is a piece of code that can be reused by other smart contracts. There are two types of libraries, deploy and embedded. Deploy libraries have their own address and they can be used by several other smart contracts. Embedded libraries don't have their own address and are deployed as part of the code of the smart contract that use them. Libraries don't have their own storage, they only provide function for other smart contracts. Give an example of how to use a library in a smart contract. In this example, we are going to use a library to add two integers. First, we define the library, and after we have a smart contract with an add function that makes use of this library. Then in smart contract A, we use the using keyword to attach the library to the integer types. That means that all the functions of the library will be callable for each integer inside smart contract A. And we can see this in action in the add function of smart contract A. So instead of just using the plus operator to add A and B, we actually use the add function of our library. And for that, we use the dot notation. So a.add, and we pass the B variable to the add function. So this add function is the add function of our library. And you will notice that even though the add function of the library takes two arguments, we only pass it one argument, because the first argument will be A in this case, and the argument that we pass between parentheses will be the second argument. When a library is embedded versus deployed, a library will be embedded if it provides internal function. Internal function can only be called by the same smart contract. Deployed libraries, on the other hand, have public functions. What is a reentrancy attack? So a reentrancy attack happens between two smart contracts. So let's consider this example. So we have a contract A and a contract B. The contract A holds some ether on behalf of some other addresses, and it has a pay function to restore this ether. And the contract B is the attacker, and it has some ether in contract A. The attack is going to work this way. So contract B is going to call the pay function in contract A. So this pay function takes two arguments, an address where we want to send the ether, and an integer amount to specify how much we want to send. So first, the pay function checks if the balance of the sender is enough. So the attacker will choose an amount which is less or equal to its balance so that this if condition passes. Then the pay function is going to call the bat function on contract B and send it some ether. And finally, it's going to decrease the balance of the sender. The problem is in the bat function of contract B, we actually call back the pay function of contract A. And when this happens, the if condition is going to pass again because at this stage, we haven't decreased the balances of the sender. So A is going to call the bat function of contract B again and send in some ether again. And the loop is going to continue until all the ether of contract A will have been drained and sent to contract B. So that's exactly what happened in the DAO attack in 2016. How to prevent against a reentrancy attack? So there are several solutions. The first solution is to decrease the balance or do other state variable update before you call another contract. The second solution is to put in place a reentrancy guard. You can find an example of how it works in the OpenZeppelin framework. And finally, you can limit the gas available to the call contract. This way, if the call contract is trying to do an attack, it doesn't have enough gas to do this. If you send ether using the transfer function, this is done automatically for you. How to produce a hash of multiple values in Solidity? First, you need to use the abi.encodePact function. You can give it as many arguments as you want. The arguments are the data that you want to hash. So this encodePact function will return a byte, which is an arbitrarily sized array of bytes, so it can have any length. But the thing is, with a hash, you want to have a fixed size length. So for that, you're going to use the Ketchak256 function. and it's going to produce a bytes 32. How to generate a random integer in Solidity? We can leverage the block timestamp and the block difficulty as a source of randomness and use the ketchak256 hashing function. First, we need to use the encodePact function and give it the block timestamp and the block difficulty. And we will hash this with the ketchak256 function. And finally, we will cast the result into an integer. You need to be aware that miners can manipulate block difficulty and block timestamp, so this method is not 100% secure. And generally speaking, random number generation is a very difficult thing in smart contract. What are the two kinds of assembly in Solidity? Functional and instructional. Functional uses a function, whereas instructional is just a series of raw opcodes. Most people use the functional style. How to declare assembly code? You need to use the assembly keyword and use curly braces. Everything inside the curly braces is assembly code. Create a function to determine if another address is a contract or a regular address. Alright, so for this you need assembly. So we're going to create a function called isHuman. So this is in regular Solidity. This function is going to accept a single address argument, that's the address to check. Then we define a code length variable, which is an integer. Then we define an assembly block, and we use the EVM opcode X code size, which can basically give us the code size of a specific address, and we store the result in the code length variable. And after, outside the assembly block, in the return statement, we check if this code length is 0. If there is no code associated to an address, then that means that this is not a smart contract, so this is a regular address, so we return true. Otherwise, we return false. So this is really a typical case of something that you can do only with assembly and not possible just with Solidity. Alright, that's the end of this video. Congratulations for following up to here. And if you want to go to the next level and train yourself on how to write Solidity smart contract, you can check out my huge tutorial on how to write 5 Solidity smart contract on YouTube. So this is for beginners, so that's really good to get started. I'll put the link in the description of this episode. Thanks for watching and see you for my next videos.